That no, he's not. Oh.
Tell him that.
Okay, hi everyone. So we're starting the class from now.
You know what?
So my name is Andy Shao. You can either call me. You can either call me Mr. Andy or Mr. Shao. First of all, do you prefer to talk in English or Chinese, or either way is okay? So okay. Okay, so we're just talking English, I guess. Sometimes I might throw like one or two Chinese words. I'm sure you should be okay with that. Okay. So why don't you just give us a brief introduction about yourself, just 1 or 2 seconds. Okay, just start from you. What's your name?
Ryan.
Ryan. Okay. You're which grade are you?
6th.
6th grade. Okay. Yeah. So what's your name? Sure. Okay.
Great.
Okay, so you're from the same school, probably? Know each other? Oh, you all know each other, right? Okay. And what about you? Jessica? Okay. So you're from 6th grade as well, right?
Yeah.
Okay. And okay, cool. Awesome. So thanks for coming, first of all. It's a pretty late weekend, so I know that everyone is make effort to make to this class. Okay. So we actually we did just for 2 years. I think it's 2013 and 2014, and I actually just got a spreadsheet from. So it's pretty good, but I'm not sure if did you do it on like on free time, or did you just try to finish everything by 45 minutes, by 40 minutes, like real test? So did you keep track of the time, or? Okay, so yeah, from now on probably you want to start to timing yourself, because like we want to just mimic the real test environment, right? So like real test you only have 40 minutes, so time control is definitely sure here. So for example, the first, I would say maybe 15 problems are pretty easy, so you don't want to spend too much time on it. So if you, so like for like maybe one problem, you for some reason you can't get the right answer, skip it. Okay, so there are some techniques, time management techniques we're going to talk about later. Okay? But you don't want to get stuck like in 1 or 2 specific problems at the early time, because you need much more time for the next 7 to 8 problems, probably from 18 to 20. Okay, so those are the hard problems. So we just go through some errors you made. I think for the year 2013, I got the following problems. I think I got number 3, number 8, 9, 13, 14, 16, and then basically 18 through 25. Okay, so yeah, so we just focus on these probably every single time, okay, because that's basically where most of you guys make mistakes. Okay. Okay, so we just start with number 3. So does everyone have the test papers here? Let's take a look at number 3. right? So for number 3, the question is find the value of 4 times -1 plus 2 minus 3 plus 4, etc. Right? So -5 plus 6, blah blah blah, until 1,000. Right? Okay. So then, of course, the second last number should be -999. Right? Okay. So if you see the pattern, I think the actually for most of the problems is that there's a certain pattern, and if you notice that pattern, that's of course based on experience, and also if you have done enough exercise, then you can see the pattern pretty quick. So for this one, what's a pattern here? So the negative, positive, etc. Right? Yes. Yes, exactly. So we try to combine the terms, right? So every 2 terms, you can see that it's always like -1 plus 2, -3 plus 4, etc. Right? So if you're just doing the addition like 2 by 2 by pairs, right? So the first pair give you 1, second pair give you 1, etc. So they'll give you 1, right? But then how many pairs are there? Yeah. 500, right? Because in total we have 1,000 number from 1 to 1,000, and then we alternate the signs, but they're still just 1,000 terms, right? So if you pair them up, then basically you have 1,000 divided by 2, which is 500 pairs. So in other words, we have 500 ones there, so we just add all of them up, you get 500 times 4, so the answer should be 2,000, right? So the answer should be E for number 3. Okay. So I think this one is pretty, it's pretty easy if you notice a pattern here. And next one is number 8. Here. Okay, so it's about probabilities, right? So, so how many of you guys have learned probability at school? I'm not sure. So all of you? Okay, cool. So some extent of probability. Okay, so number 8, you have a fair coin is tossed 3 times. 3 times fair coin. Okay. So what's the probability of at least 2 consecutive heads? Okay, so probability. So basically consecutive heads. Bigger than or equal to 2, right? Including 2. Okay, so what do you think? How do you do this kind of problem normally?
Casework?
Yes, casework, right? So we just list all of them because it's not too bad, it's only 3 times. So we can list all the possible outcomes for 3 coin toss, right? So we could have, so how many are there, first of all? So it should be 2 to the power 3, which is 8, right? So after you get all the casework, you should get 8 cases. If you miss someone, if you miss something, you will know, right? So this should be 2 cubed, right? Okay, so we just start with the easy one. So we have head, head, head. And we have head, head, tail. So we have head, head. Head, tail, head. No, I'm just listing all the possible outcomes, right? So we have head, head. No, head, 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 tail, head, tail, head, yeah, tail, head, head. Okay, so we have tail, tail, head, tail, tail, tail. Then what else do we have? We have tail, tail, head. Which one did I miss here? Head, tail, right? That's all we have. Okay, so now we just count, right? So how many of them have consecutive heads? At least 2 consecutive heads. So you have head, head, head is one of them. That's one of them. And what else? This one, right? So only 3 out of 8. So the probability should be 3 over 8. Okay? So that's for number 8. Any questions? Okay, so this one should be pretty straightforward, right? If you have any question, just let me know. Okay, then number 9. number 9. We have the incorrect compound can double the distance it jumps with each succeeding jump, right? Okay, so first of all, the jump is 1 meter. It jumps 1 meter for the first time. And then he jumps 2 meters, and then 4 meters, and so on, right? So this is the first jump, the second jump, the third jump, etc. Right? So basically, what's the pattern here? So the pattern is for the nth jump, this one should be 2 to the power minus 1, right? Okay. So when you're plugging 1, the first jump would be 2 to the 0, which is 1, 2, 4, etc. So every time it doubles the distance. Okay. So then you ask about which jump will he first be able to jump more than 1 kilometers? So I want to be bigger than 1,000 meters, right? So I don't know how many of you guys are familiar with the powers of 2. Okay, so can anyone tell me which is the biggest number? I mean, which is the smallest number that have 2 to the power n bigger than 1,000? Yes. I'm sorry.
1024.
1,024. Yeah, that's the biggest number. That's the first number that passed this number, right? So this is 2 to the power 10, right? Okay. So this is the first number that surpassed the 1,000 meters. Okay. So I think so. The answer should be C, 11, right? So I think you know how to do the problem. I think we just made a careless mistake somehow. Maybe we forgot about the first jump to start with 1, right? So the answer should be C, right? For number 9. Okay, and then number 13. Number 13. So number 13 is, so when Clara told her scores, she inadvertently reversed the unit digit and the tens digit of one score. So it's a double-digit score, right? So by which of the following might her incorrect sum have differed from the correct ones? Okay. So basically, we're trying to find the difference between the incorrect sum and the correct sum, right? So let's see a couple examples first, right? So for example, she got 72, let's say, okay? And then she accidentally put it down as 27, right? So if you take the difference, what do you have? You would have 45, right? And let's try another number. So let's see, maybe, I don't know, 81, right? So he switched the digits to get 18, right? So the answer for this one should be 63, right? Etc. Right? So get the idea. Basically, we don't know what the scores are, but by switching the tens digit and the unit digit, she got a different number, and we're trying to find out which is the possible difference between these two numbers. Okay. Okay. So these two numbers could be any number, right? So let's just use AB or XY to denote it, right? So let's say that A is the tens digit and B is the unit digit, right? And after she switched the number, she got BA. Right? Basically, B now becomes a tens digit and A becomes a unit digit. Okay? So then we can actually write down the difference, right, between these two numbers. How do you write them down? So what is AB here? Yeah. Right, so just 10A plus B. What about BA? Same thing, 10B plus A. Because B is a tens digit, so you're supposed to multiply this by 10 and then plus a single digit. Right? Okay, so then if you simplify this, right, combine the like terms, you get 10A minus A, which is 9A, and then you have plus B minus 10B, which is minus 9B. Right? So the answer is actually, if you take out the common term 9, you get 9 times A minus B. Okay, so we still don't know what this number is. Depends on your value A and B here, right? A, B could be any digit from 0 to 9, right? But we know that the answer must be a multiple of 9, right? So it's 9 times something. So the answer must be a multiple of 9. So if you look at all your answer keys here, which number is multiple of 9?
45.
Only 45, right? All the other numbers are not. So that's why only A is a possible answer, okay, for the difference here. Okay, it's number 13. Questions? Okay, number 14. 14. Okay. Number 14 is another probability problem, right? So we have AB holds 1 green and 1 red jelly beans. So let's just denote. So green is G. So we have 1 G and 1 R, right? 1 green and 1 red. And then B holds 1 green, 1 yellow, and 2 red jelly beans. Okay, so we have another person. She had 1 green and 1 yellow, right? And 2 reds. Okay. Oh, and by the way, this is I don't know how do you do the problems, but this is a good habit. So normally, whenever I see a problem, I just jot down the relevant information on a separate sheet of paper. Right? So you could have your own ways to write down the information, but normally this is a good habit because it saves you time, right? So sometimes if you don't write it down, so you might spend some other time to read it again, right? So if you write it down, it's very clear what the problem is, okay? Because you could have a really long word problem, but actually the important information maybe is only 1 or 2 sentences, okay? So you don't want to waste your time again by reading through the problems again, okay? So by doing this, I just write down all the jelly beans they have at hand, right? So we have 1 green, 1 red, and we have 1 green, 1 yellow, 2 reds. So ask about, so each randomly pick a jelly bean to show the other. So what's the probability that the colors match? Okay. So the colors match can only happen when both of them show green or both of them show red, right? So because the first person doesn't have a yellow, so there's no match over there, right? Okay. So how do you do this kind of problem? So what is the population? So what mean population is all possible outcomes, right? So how many different outcomes are there in total? Yes. There are 8.
6.
I think you're right. So how do you get 8?
Because 2 times 4.
2 times 4, right? Exactly. So for the first person, she has 2 choices. Either you can show the green one or you can show the red one, right? And for the second person, I have 4 choices, right? So we have 2 choices over here, and then we have 4 choices over there, right? So in total, if you pair them up, then you're actually doing an multiplication, right? So 2 times 4, which is 8 possible outcomes in total, right? Right. Okay, so now I just want to pick the ones that when they match each other, right? So how many cases are there when they match each other?
Cases.
Yes, so basically here we have 2 reds. So you can think about this as red 1 and red 2, right? So you can choose to either give red 1 or red 2. Yes, so there are 3 cases. Okay, so just be careful here. So it looks like there's only a red here, but actually you can either give the first one or the second one. So there are 2 choices there. And then for green one, there's only 1, right? So green and green, and then we have red, red 1, and red, red 2. So 3 cases when they match. So the probability should be 3 divided by 8. Okay? So the answer should be C, number 14. Okay, and then number 16. Number 16. Okay, so it's a pretty long word problem here. So number of students from Fibonacci Middle School are taking part in a community service project. So we know the ratio of the 8th grader to the 6th grader is 5:3. 8th grader divided by the number of 6th grader is 5 divided by 3. Okay. And then we also know that the ratio of the 8th grader and the 7th grader, 7th grader is 8/5, right? Okay. And then you ask about, well, what is the smallest number of students that could be participating in the project? I want the smallest number of students in total, right? Smallest possible students in total. Otherwise, there are many possibilities because you're only given the ratios, right? So the numbers could be arbitrary as long as they have this ratio in between the numbers. Okay, so how do you do this kind of problem? Have you done the ratio problem before? Okay. So for example, you can see it from here that the 8th grader seems to be the common factor here, right? Okay, and the 6th grader and 7th grader, we don't really know about their numbers. But for 8th graders, so we know that this one is 5/3 and that one is 8/5. So it seems like the 8th grader's number should be both multiple of 5 and multiple of 8, right? So it's kind of like a hint, right? So how do you get the smallest possible number for the 8th grader, first of all? Right, just 5 times 8, because they're prime to each other, right? So the smallest number that can divide both 5 and 8 at the same time has to be 5 times 8, right? Which is 40. The smallest possible number for the 8th grader, right? So after we figure this out, then everything is very easy, right? Because we know this is 40. So then correspondingly for the 6th grader should be 24, right? And then if you here you have 40, then the 7th grader should be 25, right? So then you just add them up. And the answer, I think for number 16 is E, right? So if you add all of them up, you should be able to get 89, the total number of students. Okay, questions? Okay, so let's look at 18 through 25. Oops. So number 18. Okay, so Isabella used 1-foot cubicle blocks to build a rectangular fort that is 12 feet long, 10 feet wide. So let's just write L is 12, W is 10, and 5 feet high, right? So then we know the floor and the four walls are all 1 foot thick. Okay, so 1 foot thick for the material, basically, to building the fort. Okay, so how many blocks does the fort contain? So ask about how many blocks. So we know that each block is a 1 foot cubic block, right? So 1 foot cubic foot block. So ask about how many blocks are there. Basically, you're asking what's the volume, right, of this thing that built this fort, right? Okay, so I think the picture on the page is pretty good. I think that's better than what I can draw on the board. So I just use that as a picture. So how do you find the volume of this thing here? So yes, you should.
You find the volume of we subtract the value of the 10 by 4 by 8.
Right. So basically, the idea is this one is not a regular shape, but we can find out its volume by taking the outside cube minus the inside cube, right? So this volume is a difference between the bigger one and the smaller cube, right? So what's the dimension of the bigger cube? We already given, right? So it's 12 by 10 by 5. It's 12 by 10 by 5 is this whole thing. And then what about the inside? So for the inside, you should take up 1 foot from each side, right? So for example, for the lens, it's right. So 1 from each side, so it should be 2, right? So you have 12 feet long, so you should take off 2 from each side. And then for the 10 feet wide, you should also take off 2. And the interesting is about the height. So how many should we take off from 5? Only 1, right? Because this one's hollow, so we only count the one on the bottom. I think some of you might make a careless mistake over here. So this one is open, right? So we only have a base that has a thickness of 1 foot. So only take up 1 foot from 5. So if you compute this number here, that's 12 times 10 times 5 is 600 for the bigger volume. And the smaller volume is 10 times 8 times 4, right? So 320, right? So the answer should be B, which is 280. That's number 18 and number 19. Number 19 is a logic problem, right? So we have Bridget, Cassie, and Hannah are discussing the results of their last test, okay? So we denote B, C, and H, right? So we have 3 persons. So we know that Hannah shows Bridget and Cassie her result, okay? So Hannah shows both of these 2 persons her result, but Bridget and Cassie didn't show their test to anyone, okay? So they just know their own test result, basically. Right? Okay. So then, what did they say? So Casey says I didn't get the lowest score in our class. Okay. So C, after she see her own score and H score, she know that she's not the lowest. So which means that C must be bigger than H, right? Okay. And then similarly, we have Bridget's. I didn't get the highest score. Okay. So after she see her own score and H scores, she know that she's not the highest. So basically it means that B must be less than H. So I think it should be from the highest to lowest should be C, H should be, right? So the answer should be D, right, for number 19. Number 20. So we have a 1 by 2 rectangle is inscribed in a semicircle with a longer side on the diameter. Okay, so we have, so we draw a picture, it looks like something like this. It's 1 by 2, right? Sorry. So I don't have a picture for my papers, I think. Do you have a picture of that? So ask about the area of a semicircle. Right? So I think So I think if it's 2 by 1, so that's 2, that's 1, right? And this center is here, so this one should be 1. Yeah, this one should be 1 as well. So it would have the radius of this circle would be square root 2, right? By Pythagorean theorem. So then the area of the semicircle would just be pi 1/2 pi r square, which is pi, right? So number 20, the answer should be C. Okay, so then number 21, I think it's should draw the picture correctly. It's a pretty long problem, so let's go through that. So we have Samantha lives 2 blocks west and 1 block south of the southwest corner of City Park. Okay, so it has a southwest corner of the park, and her home is actually 2 blocks to the west and 1 block to the south. So it's somewhere here, right? So this is Samantha's home. So it's 2 blocks here and 1 block there, right? So this is 2, that's 1. Okay. And then her school is 2 blocks east and 2 blocks north of the northeast corner of City Park. Okay. So basically the park has another corner here, right? And then your school is actually 2 blocks up and 2 blocks to the east, right, to the north. So it's basically 2 by 2. So school is somewhere here. Right? And then on school day, basically she bikes on streets to the southwest corner of City Park. So this is the southwest corner, right, of City Park. So she biked from home to here, and then takes a diagonal path through the park. Okay, so basically it goes this way here, through the park, and then to the northeast corner, and then bikes to the on street to school. Okay, so then from here to school, you just bike again, right? Let's draw a picture like that. It's more clear. Okay, and then if her route is as short as possible, then how many different routes can she take? So first of all, have you done this kind of problem before? Like from one point to another point? Yeah. So what kind of tool will you use in order to solve this kind of problem? Choosing. Choosing, right. Or so how many of you guys have learned combination and permutations? Got it? Okay, all right. So basically, so we're trying to figure out how many possible ways, different combinations in between here and there, right? So how many choices can she make from the point? So let's use point A, point B, and point C to get out these 3 points. Maybe C and D. Okay, so basically her route only depends on how she make it from A to B. So from B to C is fixed, right? So it has to cross the park anyways. So this route is fixed. And then from C to D, she can take many other routes as well, right? So 8 choices. Okay, so from A to B, how many choices can she have? Biking from A to B. It's 3 choose 1, right? So why is that 3 choose 1?
You have to go up 1 sometimes, so you can choose what now. It's your first time. It's your first time.
Yes, that's very good. So basically, you have to make 2 moves to the right and 1 move up, okay, in order to get from point A to point B. But you can choose when to move right, when to move up, right? Okay, so in other words, you have 3 possible moves, and 1 of them should be up, right? So that's why you can choose 1 from 3, which means you can choose 1 of these 3 moves to be up move. And then the other 2 moves automatically becomes the right move, right? So 3 choose 1 is 3. So basically, she has 3 different ways to get from point A to B. So you can actually draw it out because the number is very small. So this is 1, that's 2, that's 3. It's only 3 choices. Okay, so similarly here, from the point C to point D, we have two. She has to move. She has to make 2 right moves and 2 up moves, right? So 2 right and 2 up, and she can choose when to make the up moves among these 4 moves, right? So it becomes 4 choose 2, which is 4 times 3 over 2 times 1, which is 6, right? So in other words, there are 6 different choices she can make from the point C to point D, right? So if you want, you can try to draw all the routes by yourself, okay? But if you get all of them, it should be 6 different possible routes, okay? So then in the middle, this one's fixed. So the choice should be 3 times 6, which is 18. So that's the total number of choices. So it's a combination between the choices here and the choices over there. So the answer should be E for number 21, right? Any questions here? And 22. Okay, so number 22, we have toothpicks are used to make a grid that is 60 toothpicks long and 32 toothpicks high. Okay, so we have 60 long and 32 high or wide, right? Doesn't matter. So let's say high. And then you ask about how many toothpicks are there we used, right? So how many toothpicks? Okay, so for this kind of problem, if you're not quite sure, so this one is again a common trick. So for big numbers, if you're not quite sure how to do it at first, try some small numbers. Okay, and from the small numbers, you might see the pattern, and then you can generalize it to a big number like 60 and 32. So instead of 60 by 32, let's try 3 by 2. So it's very easy, right? So we have 3 matches long, 3 sticks long, and 2 sticks high, right? Something like this, right? Okay, so for this one, how many sticks do we need in order to form this shape? Okay, so now you can see that there are 3 columns, right? So if you look at the squares, there are 3 columns, right? But if you look at the sticks that making up these 3 columns, you have actually 1, 2, 3, 4 vertical sticks, right? 4 vertical sticks to make up 3 columns, right? Okay. So if you're just counting all the, so for this kind of problem, actually we're counting them separately. We're counting the vertical ones, and then we're counting the horizontal ones, and then we add them together. Okay. So now for the vertical ones, for the first row we need 4 of them, right? And same thing for the second row, we also need 4 of them, right? So in other words, we have actually just 4 times 2, which is 8 vertical sticks. Right? Okay. And then what about the horizontal ones? So for the horizontal sticks, we also count it this way, right? So we have only 2 rows, right? If you look at the square, we only have 2 rows, right? But if you look at the sticks, we actually, in order to make up these 2 squares, you need to have 3 horizontal sticks, right? So these 3 sticks for the first column, right? And then for the second column again, you need 3 of them. And the third column again, you need 3 of them, right? So if you count the horizontal ones, you would have 3 times 3, which is 9 horizontal sticks. Right? Okay, so now you can see what's the pattern here. So remember, originally we have a 3 by 2, right? So we have 3, yes, 3 by actually 2 by 3, right? So two rows and 3 columns. Sorry. 2 rows and 3 columns. And answer is actually 8 plus 9, which is 17. Right? And then you actually kind of look at how do we count the vertical sticks and the horizontal sticks together, right? So how do we count the vertical sticks? So it's 4 times 2, right? So how do we get the 4? We know that it's 3 columns. So why we need 4 sticks? Well, because you know that for vertical ones, you need 4 to enclose 3 squares, right? So it seems like you're multiplying the number of rows 2 by the number of columns plus 1, right? So that's when you do the vertical sticks. This one is for the vertical. And what about this one? 3 times 3, what do? You have the number of columns multiplied by the number of rows plus 1, right? 2 plus 1. And the reason is the same, right? Because in order to enclose 2 squares, you need to have 3 horizontal sticks, right? So that's why you add 1 to the number of rows, and this one you get the horizontal ones. Okay. So then how do you generalize this to a general case? So for example, if you have not 2 by 3, let's say you have n rows and m columns. So what's the result? Same thing, right? So for the vertical, how do you count vertical? So this one is 3 plus 1. So here, if you have m columns, you would have m plus 1, right? M plus 1 times the number of rows, which is n, right? So this is the case for the vertical sticks. That's how many do you need in order to form this, right? And then for the horizontal ones, what do we have? We have m times n plus 1, right? Okay. And then the total number of sticks, we just add them up, right? So vertical plus horizontal. So we have vertical plus horizontal equals n times m plus 1 plus m times n plus 1, which is, if you simplify this, you get 2mn plus m plus n. So you can actually remember this as a general result. So now in the future, no matter how many sticks are there, you can always use this formula, okay, to get the answer. So in this one specifically, we get 60, what do we have? We have 62 sticks long, right? So basically means that n is 60. And then we have m is 32, right? 32 high and 60 long. So you just plug in to the formula. This would be 2 times 60 times 32 plus 60 plus 32, right? So the answer should be, I think it's E, 3932. That's number 22. The answer is E. Okay. Any questions so far? Okay, number 23. Number 23 is Pythagorean theorem again, right? So we have a right triangle, ABC. ABC. And each one is actually, the size of the triangle are the diameters of the semicircles, right? So semicircle here, semicircle there, and semicircle here, right? Yeah. Okay, so now you're given some information. You know that the area of the semicircle on AB is 8 pi, right? So this area here, you know, is 8 pi. So you can figure out AB, right? So what is area here? So it's 1/2 pi r square equals 8 pi, right? So r square equals 16, r equals 4, right? So in other words, the radius here should be equal to 4. So AB is 8, right? AB is a diameter, so it's 8. 2 times r. right? And similarly for the arc of the semicircle AC is 8.5 pi. Okay, so this time you're not given the area, but you're given the arc length, which is the same thing, right? Because we know the arc length AC is half of the circle, which is pi r, right? That's 1/2 2 pi r, which is pi r equals 8.5 pi. So know that r for the AC is actually 8.5, right? So once again, the AC is a diameter, so it's 8.5 times 2. AC is 17, right? 17, 8, and then you ask about what's the radius of the semicircle in BC. Okay, so just Pisaghian theorem, 17 squared minus 8 squared, take a square root. And then don't forget to divide by 2, because we know we want to find the radius, right? Not the diameter. So number 23 is B, which is 7.5. Okay, number 24. So again, a geometry problem. Right? So A, B, C, D per square. And then you have E, F, G, H. This is the middle point here. And then you have another square, which is H, I, G, H, I, J, right? So A, B, C, D. So we have I and J. So we know that the only thing we know is these are all equal in area. So these are all congruent squares, right? So same length and same area. And then we also know that the points C and D are middle points, right? So C and D are middle points of DH and HI. So you asked about what's the ratio of the area of the shaded pentagon AJICB, right? So A, B, C, I, J. So it's basically you connect A and J together, and then you have something like this, right? So connect these two parts together, you get a pentagon, right? Okay, so then basically you're trying to find the area of this pentagon and then divide by the sum of the area of these three squares, right? So how do you do that? So if you look at the graph, how do you find the area of the shaded area? Yeah.
So since D and C are the midpoints of EH and HI,
Yes.
you can draw like two lines. Like you can make a triangle.
You can make a triangle.
You can make a right triangle, and then like so since D is the midpoint of EH and C is the midpoint of HI.
Yes.
If
you want, you try to cut this into like two pieces, right? And try to add them together. Yeah.
You subtract the rectangle over there.
Are you trying to do something like this? That seems like the most straightforward way to do, right? Just by drawing like two lines here, you can see that it's easy because after you draw this, you actually get a bigger one, which is a triangle, and the smaller one is a square. Not square, a rectangle, right? So I think this is the most easy way to do it. So then, of course, you need to have some numbers, right? Because you're not given any length or anything. So you can suppose AB, for example, is 1, right? Because we're trying to find the ratios, so it doesn't matter, right? So we can suppose any length we want. So suppose AB is 1, And then we know that this is a middle point. So we know, so let's call this point K. Right? I'm just trying to find the next letter here. So we know that BK is going to be 1/2, right? Because BK is the same thing as CI. So you have 1 and 1/2. So AK is basically 1 plus 1/2, which is 3/2, right? So that's the base of this triangle. And then the height of this triangle would be KJ. So what is KJ here? It's going to be IJ plus KI. It's just 2, right? So KJ is just 2. That's 1 plus 1, right? And then, of course, the area of this thing here, AKJ, triangle AKJ has area equal to 1/2 times 3/2 times 2. So it's basically 3/2, right? And what about the little rectangle here? So it's going to be 1/2 times 1, right? Which is just 1/2, right? Okay, so if it takes the difference, you get 3/2 minus 1/2, which is just 1, right? 2/2. Okay, so in other words, the shaded region actually has area 1, and then if you sum up all 3 squares, you get 3, right? So it's going to be 1/3. So the answer is C, right? Number 24. Okay. I think the trick is only if you draw these 2 lines, that's very easy to figure out, right? I'm sure there are some other ways to do it, like you break this up into small pieces, but this one is the most straightforward way to do it. Okay. So last one, 25. Okay, so by the way, just because it's the last problem doesn't necessarily mean it's the hardest one. Okay, so don't panic when you go to like 20 to 25. They're not necessarily hard. It's just if you have done enough exercise, you know all the tricks, and you know how to solve the problem. Okay? So for number 25. You have a ball with radius 4 inches. Start at the point A to roll along the track trail. Okay. So let's draw a picture here. So we have a ball here, and then we have all semicircle tracks, right? So we have a track here, another track over there, right? So the radius are R1, R2, and R3. Okay? Okay, so it's a pretty nice track over there. Okay, so we know some numbers. So R1 we know is 100, and R2 60, R3 is 80. Okay, and the ball has diameter 4 inches, right? So diameter of the ball is 4. Okay, so ask about what's the distance in inches the center of the ball travels over the course from A to B. Okay, so this is a point A, that's a point B. You're not asked about how long does the ball travel. Right? That would be easy because you're just adding up all these 3 lengths of semicircles. But instead, you're asking about the center travels how much distance, right? Let me draw a circle, maybe in a different color. Yeah, so center, right? So how do you do this kind of thing? So how do you need to somehow track the center, right?
The diameter is 4, so the radius would be 2.
Right, so radius of the ball would be 2.
So on the first semicircle, since the ball is closer to the center than the track, it's
right
above the track.
Yes.
Then we subtract 2 from R1.
Right. That's very good. Okay. So basically you have to break this up into 3 pieces, right? So if you look at the first piece, your ball just roll along the track and ends up here, right? Now you can see the center actually travels a different route than the ball itself, right? So if you look at, for example, this point on the ball, I mean on the ball itself, so this actually travels a whole semicircle, right? From the point A, say, to the point C, right? But if you look at the center actually travels a smaller semicircle, right? The center's trajectory is actually something like this, right? So it's still circle, but the radius is a little bit smaller, right? So what's the radius for this smaller circle here? I think it's going to be 98, right? Because the whole radius is 100 divided by 2. No, already given the radius, right? Yeah, so it is a radius. Yeah, so it's 100 minus 2, which is 98. So this is for the first trajectory, right? So it's a little bit smaller. There's a semicircle. So basically, the distance it traveled would be 1/2 times 2 pi r, which is pi r, which is 98 pi. The first one, right? Okay, and then what about the second part? For the second part, it goes through this, right? But now it actually travels a bigger semicircle, right? Because it's on top of the track. So if you look at the center, it actually travels, I mean, the trajectory itself is still a semicircle, but you should add the radius to the original radius, R2, right? So for the second part, it should be 60 plus 2, right? And the radius will be 62. And then we compute this again. So it's again 1/2 times 2 pi R2, which is 62 pi basically, right? And then similarly for the third track, it's again minus, right? Because now it's unit track again. So this is a smaller semicircle, so it would be 80 minus 2. So which would be 78 pi, right? So the total distance, of course, is you just add them up. So you get, so for this one, it's 238, right? So the answer is 84. Okay, any questions? Am I going too fast or too slow? You can let me know. Or it's okay? Okay, all right, cool. So let's take a short break, maybe 2 minutes, and we come back and we talk about the other problem, set of problems, okay? The bathroom is back there, actually.
Are you going to read it?
Well, you can read that. And all these things.
It's like don't usually find it for that because of what
Okay, let's go back to class. So for the year 2014, I got number 2, 9, 10, 11, 13, 16 to 25. Okay. Okay, so let's go through the easy ones first. Number 2. Number 2. Okay. So Paul's pocket 35 cents and has a pocket full of. Okay, so we have 35 cents. There's a total amount of money she has to pay back, right? I mean, he has to pay back. And then he only have like 5 cents, 10 cents, and also 25 cents. Okay, so you ask about what's the difference between the largest and the smallest number of coins she can use to pay her. So what's the largest number of coins she can use? 7, right? Because he's trying to use the smallest possible coin to pay her back. So it's going to be 35 over 5, which is 7. So what about the smallest? The smallest would be 2 because you only need to use a 25 and a 10, right? So it's just 25 plus 10. So number is 2, so difference would be 5, right? So the answer should be B for number 2. And for number 9, we have a triangle ABC, and then we have D as a middle point. Not a middle point, but we have BD equals DC, right? So if BD equals DC, then what do we know about the angles? So if this is 70, that's also 70, right? And there, you ask about the angle ADB, which is 70 plus 70, which is 140, right? So this one is also pretty straightforward. The answer should be D for number 9, right? It's 140. Any questions? So it should be pretty straightforward. I think if you made a careless mistake, just be careful next time. Okay. So, and number 10. Okay, so the first AMC 8 was given in 1985. So that's the first one. And it has been given annually since that time. And Samantha turned 12 years old. The year she took the 7th AMC 8. Okay, so 7th AMC 8 would be, if you just add 6 to it, so you get 1991. Right? So that's a year when you have the 7th AMC 8 test. And then she is 12 years old at that time, right? So what year is she born? So just to subtract 12 from 1991, right? So I think this one is also pretty straightforward. For number 10, the answer is A, right? Which is 1979. Okay. Any questions on that? Okay. So number 11. Jack wants to bike from his house to Jill's house, which is located 3 blocks east. So this is again. So we have done a similar problem like that before, right? Remember, in the 2013 one, so it's again just right from one point to another, right? Okay, so this is Jack's house. Yeah, Jack's house is down here, and then Jill's house is somewhere there, which is located 3 blocks east. So 3 blocks east, and then 2 blocks north, right? So 2 blocks north. Okay. So after biking each block, Jack can either continue east or north, but he needs to avoid a dangerous intersection, which is 1 block east and 1 block north of his house. So basically, there is a dangerous spot here for some reason. A dangerous intersection here, 1 block north or 1 block east, right, from where he is. Okay, so then you ask about in how many ways can he reach Jill's house by biking a total of 5 blocks. Okay. So this is again a similar problem, right? Because he has to make 3 moves to the right and then 2 moves up, right? So if there is no dangerous spot like that, how many different ways can he get to her house? How many different routes? 5 choose 2. Yeah, is that 5? Yeah, it's 5 choose 2, which means we have 3 right moves and 2 up moves, and you can choose 2 of them to be your up move, right? So if there is no restriction at all, then there are in total of 5 choose 2, which is how many? 10 different routes, right? Okay, and then out of these 10 routes, some of them go through this restriction block, right? So how many of them go through this block? Yeah. So how do you get 6? 6 is the right answer. So of all the routes here, of all the 10 routes here, 6 of them go through this point. And how do you know? Because if you want to go through this spot, so you can think about this as a middle point. So you have to get here before you get to Jill's house, right? So instead of thinking about you have 2 routes, instead of looking at the routes directly, you have to make a stop here somehow, right? And then start from here, you go to Jill's house, right? So it's a similar problem like the one we did before. So if you're from Jack's house to the dangerous spot, there is one step to the right and 1 step up, right? So there are a total of 2 choose 1 different ways to get to that spot. right? And then from this spot to Jill's house, you have to make 2 moves to the right and then 1 move up, right? So in total of 3 moves, then you choose one of them to be up move. So it's going to be 3 choose 1, which is 3, right? So there are in total 2 times 3, which is 6 different routes. That's going to stop in the middle somewhere, right, at this spot. And we actually want to avoid this spot, right? So then basically we take the difference. So we have 10 minus 6, which is 4, right? So 4 different routes that will avoid this different spot. And then of course, this is kind of a long way to do it. So if the numbers are small, you can actually just count, right? So how many different routes can you go around this spot, right? And then go to Jill's house. But when the numbers are big, I think this is a systematic way of solving this problem, right? So just you use a total number for routes, subtract off, we use this dangerous spot as a middle point to get to Jill's house. The idea are the same, right? So the answer for number 11 is 8, right? 4. Okay, and then number 13. Number 13, we have n and m are integers, and we know n squared plus m squared is even. Then which of the following is impossible? Okay, so we're given 5 scenarios where one of them is impossible, right? Okay, so the first one, we just go through the results one by one, right? Answers. So first one, n and m are both even. Is that possible? That's possible, right? Because even number squared plus even number squared is even number. So, and what about the second one? N and m are both odd.
Yes.
That's also possible, right? Because odd number squared is odd, and this one is also odd. So odd plus odd is also even, right? That's okay. So the third one, n plus m is even. Is that possible?
Yes, because for opposite has to be either.
Okay. So this one is a little bit tricky, right? So we asked about n plus m, right? Is that even? If that's even, actually we could have n and m are both even or both odd, right? So in both cases, we can actually make this even. So that's okay, right? So C is also okay. And what about D? D is n plus m is odd.
No.
So why is that not possible?
Because if n squared plus m squared is even, n plus m squared with a parenthesis.
Okay.
Must
So you're saying this, right? Equals
n squared plus m squared plus 2nm.
plus 2mn.
And since the 2mn must be even, we can subtract that
Yes.
from it, and then that doesn't actually change if it's even or odd.
Exactly. So basically, you can look at this formula here. On the right-hand side, we already know n squared plus m squared is even. So this part is even, right? And that part is also even because you're multiplying 2 by it. So of course it's even number, right? So you're adding 2 even numbers. So basically we know that on the right-hand side, it has to be even. Right? Okay. So now on the left-hand side, if you have an odd number for n plus m, then odd number squared is going to be odd. So that's going to be a contradiction, right? So in other words, this n plus m can be odd. Right? So this is based on this formula here, right? Or we can just think about, so what happens when n plus m is odd? Then it has to be the case that one number is odd, one number is even, right? That's the only case when n plus m is odd, right? Okay, so if one of n and m has to be odd, then this one can be even, right? Because you have an odd number in between these two numbers. So one of the square has to be an odd number. Then if you add them up, you get an odd number, right? So the answer for number 13 is D, right? It's just basically the property of odd and even numbers, right? So, so number 13, and number 16 through 25. Okay. Part number 16. This is also one of the very commonly tested questions. So we have the middle school 8 basketball conference has 8 teams, right? So in total we have 8 teams. And every season, each team plays every other conference team twice, home and away. Okay, so basically 2 games against all the teams in this league, right? So 2 games against all the other teams, right, in the league. And then we have 4 games against non-conference opponents, right? So we have 4 games against non-conference. So basically means some other teams from outside, right? Outside teams. Okay, so then you ask about what's the total number of games in a season that every team has to play. Okay, so basically you have to add up 2 parts, right? The first part is all the games against each other, against the teams in the league, right? And then you have to add up all the games against outside, right? So outside is easy, right? Because each team has to play 4 games against outside teams. So we have 8 teams in total. So it's going to be 8 times 4, which is 32, right? So that part is easy. So what about the in-league games? How many games are we playing together in total? Yes. So it's 8 times 7 divided by 2. How do you get this number? That's the correct answer.
Well, actually, I think it's times 2 because 2 games.
Oh yeah, 2 games each. So it's basically just 56, right? So how do you get this? Yeah. So there are actually 2 ways, right? So sigma is one way, right? Because so we can leave the 2 outside. So because each team has to play against another team 2 times, right? So this is just a common multiplier. We just leave it outside. It's okay. And then if you just focus on the team, so let's see, write it down. 1, 2, 3, 4, 5, 6, 7, 8. Right? Okay. So the first team has to play against 2, 3, 4, 5, 6, 7, 8, right? So it has to play 7 games against all the other components, right? Then what about for the second team? I don't want to count this again, right? So I already counted once. So 1 is going to play 2. So we're going to count it from 2. We have 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, and 2, 8, and so on, right? So we're going to play against 6 teams for number 2. And then similarly for the third team, I don't want to count back again. So it's just 3, 4, 3, 5, 3, 6, 3, 7, 3, 8. So it's going to be 5, etc. until 1, right? So that's the total number of teams if you're only counting the home games, right? Okay. So this one actually gives you 8 times 7 over 2, right? So this is 8 times 7 over 2. And then, of course, each team will play both a home game and away game, right? So then you should multiply the result by 2 to get the answer 56. Okay. So that's one way to think about this problem. Okay. And another way to think about this problem is actually easier. You don't have to add all these things up. Okay. So you can just think about. I'm sorry.
Double counting?
Yeah, double counting. So it's basically if you play against a opponent, right? So it's counted as a home game for you and the away game for the other component, right? So basically, you can just think about for each team, you have to play 7 games, right, against all the other different components. And then for the second player, he also has to play 7 games, no matter if it's home or away, right? So your home is another team's away, basically. So basically, we're just adding up all these 7s. You have 8 of them, right? So to think about it carefully, actually, in this way, you're actually counting both the home and the away game all together. Okay, so this one is even easier. It's just 7 times 8, which is 56. Okay. Okay, so that's a game played in the league, and that's a game out of the league. So if you add them up, you get the answer, which is 88. Right? So the answer for number 16 is B. I think this one is a little bit tricky if you haven't seen this kind of problem before. Okay, let's see number 17. Okay, so number 17, George walks 1 mile to school. She leaves home at the same time each day, walking at a steady speed of 3 miles per hour. So 3 miles per hour is his speed. And the distance is 1 mile, right? Okay, and today he was distracted by a pleasant weather and walked the first 1/2 mile at a speed of only 2 miles per hour. So 2 miles per hour for the first 1/2 mile, right? And now you ask about at how many miles per hour must George run the last 1/2 mile? So the other 1/2 miles, he has to speed up, right? Because he's kind of slowing for the first half, right? So in order to catch up, he has to run at a different speed, right? So you ask about how many miles per hour must he run in order to just arrive at school beginning today. Okay. So this one, I think you just need to figure out the time, right? That you need to spend from school to from home to school, right? So from here you already get it because the total distance is 1 mile, and the Euro speed is 3 miles per hour for him, right? So what's the time here? It's just going to be 1 divided by 3, right? Hours. In other words, 20 minutes, right? To get to school. Okay. And then today, because he ran at 2 miles per hour for the first 1/2 mile, so the time he spent here is going to be 1/2 divided by 2, which is 1/4 hour, right? Which is 15 minutes, right? Okay, so in other words, he only have how many minutes left? 20 minus 15. Only has 5 minutes left in order to cover the other 1/2 mile, right? So what is 5 minutes? 5 minutes is 1/12 hours, right? So you want to keep track of the units, right? So 1/2 hours to cover 1/2 miles, okay? So then the speed must be 1/2 divided by 1/12, which is 6 miles per hour, right? Okay, so the answer should be B, right, for number 17. All right, so number 18. Number 18. Okay, so we have four children were born at the city hospital yesterday. Assume each child is equally likely to be a boy or a girl. Which of the following outcome is more likely? Okay, so this one is again a probability problem, right? So you just compute the probability for each of these 4 cases, right? So first of all 4 are boys. What's the probability? All 4 boys.
1/16.
It's going to be 1/16, right? So total 16 outcomes, and out of them, only 1 of them is a possible outcome. So what about B? All 4 are girls, same thing, right?
Yeah.
1/16. Only 1 case out of 16 cases. And 3, C, 2 girls and 2 boys. So probability we have 2 boys, 2 girls. Yes, so it's going to be 4 choose 2, right? So that's a different combinations, right? So we have 4 choose 2 divided by 16, which is 6 over 16, which is 3 over 8, right? And then we have 3 of one gender and 1 of the other gender, right? So it doesn't specify the gender here. So it could be 3 boy and 1 girl, and it could be 3 girl and 1 boy. So what's the probability here? So it's going to be 2 times because it's symmetric, right? So the probability of 3 boy and 1 girl is the same thing as the probability of 3 girls and 1 boy, right? So again, we have 4 choose 1 divided by 16, which is what is that? 4 over so 1/4. So it's 1/2. What is that? Is that 1/2?
Yes, that's
4 over 16. Yeah, that's 1/2. Okay, so you can see which one is the biggest. It should be D, right? So the answer should be D for number D. I think the only tricky part is D is actually 3 of the one gender and 1 of the other gender. It didn't specify the genders. So you might make a mistake over here. For D. Okay. Okay, and then number 19. So number 19 is you have a cube with 3-inch edges to be constructed from 27 smaller cubes with 1-inch edges. Okay, so we have 27 small cubes, right? 3 by 3 by 3, basically the most general Rubik cube we have. Okay, so then we have 21 of the cubes are colored red. So 21 are red colored, and then the small cubes, right? And 6 of them are white, right? And then if the 3-inch cube is constructed to have the smallest possible white surface area, so we want to have the smallest possible white surface, right? Possible white surface area. Right? Then you ask about what fraction of the surface area is white. Okay, so this one actually requires some kind of thinking, right? So how do you arrange the white cubes, right, to form this big Rubik cube? Okay. So first of all, I want the smallest possible white surface. What does that mean? So I want to. So for example, if you have a white cube on the corner, now how many surfaces do you have? 3, right? So if you have a white at the corner, so that's actually gives you 1 cube will give you 3 surfaces. That's pretty big. We don't want that, right? We want the smallest possible surface. So you can see that where do you put the cube in order to have 0 surface? In the middle, right? So if you put that in the middle, basically it's going to have 0 white surface, right? And then is there any other cases? If you put it on the edge, right? Not on the corner, but the one next to the corner, now how many cases are there? 2, right? So basically, depending on the position of the white cube, you could either have 0 surface, you have either 0 surface, you could have 1 surface, 2 surface, and 3 surface, right? The maximum is 3 surface, right? Because that's when you put it on the corner, so we don't want that to happen. Okay, so how do you get 1 surface?
If you put it in the center of a side.
Exactly. So if you have like a side looks like this, right? So if you put it in the center here, if you put it here, right, it's gonna, that's the only surface that is 1. All the other is inside, right? And if you put it here, that's gonna be 3 surface. If you put it there, you get 2 surface. So that's 1. Right? Okay, so now you only have 6 of them, right? So how do you arrange them to get the minimum possible surface? Yes. You put one in the middle, right? And then you have 5 left. How do you arrange these 5?
You put all the 5 in whatever, like for each side.
Mm-hmm.
Yeah. So for 5 of the sides, you put the rest of the white cubes in the center of the side.
Exactly. So you put all of them in the center because you have 6 sides in total, right, for a cube. So you could actually choose 5 of them and just put the white ones here, right? And that's the best way to minimize the amount of surface because we didn't even use these 2 surface and 3 surface. We didn't put them there, right? So we have enough 1 surface spot to put in the squares, right? So the way to do it is you put 1 here in the middle for 0 surface, and then you put the rest 5 to the ones where you have 1 surface, right? So what fraction of the surface area is white? So you can see that you only have 5 out of how many possible. So what's the total surface area? 6 times 9, right? You have, for 1 surface, you have 9 of them again. You have 6 surfaces, right? So you have 6 times 9, which is 54. So it's 5 over 54 is a fraction here, right? So the answer for number 19 is A. Okay. Number 20. So we start off a little bit late. So I just, it'll be another 5 minutes probably. Okay, sorry. So for number 20, I think 20 is pretty straightforward. You have a circle A, circle B, and circle C, right? So it's A, it's B, C, and D. Okay. Okay, so the rectangle has CD is 3. Okay, so DA is 5. Okay, so circle of radius 1 is centered at the point A. So the radius here is 1, and then circle of radius 2 at the point B, and circle radius 3 at point C, right? So which of the following is the closest to the area of the region inside the rectangle but outside all 3 circles? So basically we're asking about this area here, right? So how do you do it? Well, you compute the area of the rectangle, and then you compute 1/4 of the big circle, 1/4 of the circle C, 1/4 of the circle B, and 1/4 of the circle A, right? So this one should be pretty straightforward. I'll just give you the answer directly. For number 20, the answer is B. Number 21. So we have 7 digits, each are each multiple of 3. So we have 7, 4, A, 5, 2, B, 1. That's the first number. And then the second number is 3, 2, 6, A, B, 4, C. Okay, so they're both multiple of 3, right? So which of the following could be the letter of C? Okay, so first of all, for a number that is multiple of 3, what property does it have? If you add up all the digits, it has to be multiple of 3, right? So if you add up the first number, what do you have? You have 7 plus 4 plus A plus 5 plus 2 plus B plus 1, right? Which is A plus B plus 19, right? So we know that this must be a multiple of 3, right? So this one is a multiple of 3. And then if you add up the second number, you get A plus B plus C, and then plus 15, right? So this one is also a multiple of 3. Okay, so then basically, what do you know about a plus b?
It must be. It must be a multiple of 3 subtract 1.
It must be a multiple of 3 subtract 1, basically, right?
Would that
Why
be
subtract 1?
Would that be like 3 log 2 or something?
Yeah, you could say that, but okay, so basically what we know is, so 15 is a multiple of 3 by itself, right? So this is a multiple of 3 by itself. And then we know that a plus b plus c must be a multiple of 3, right? Okay, and then we know that a plus b is a multiple of 3 minus 1, right? So then how do you balance it? So basically this is a multiple of 3 minus 1, then this c must be a multiple of 3 plus 1, right? Does that make sense? You want to balance that minus 1, right? Then if you add all of them up, you would get 1 by 3, right? So if you look at all the answers, I think only one of them, right, which is 1. So the answer for number 21 the answer for number 21 is A. Number 22. We have a 2-digit number is such that the product of the digits plus the sum of the digits is equal to that number. So what's the unit digit of this number? So once again, we just set this up as AB, right? So it's a 2-digit number. So we know that the product of the digits, so A times B, plus the sum of the digits, which is A plus B, is equal to the number, which is 10A plus B, right? So then if you solve this equation here, so B and B will cancel, right? So we have A times B equals 9 times A, so get B equals 9, right? Solve this equation, you actually get B equals 9 directly. So the answer is E for number 22. Right? Number 23. So I have 3 members of the middle school girls sub team have the following conversation. We know, so Ashley said, I just realized our uniform numbers are all 2-digit primes. Okay. And then Bethany said the sum of your two uniform number is the date of my birthday earlier this month. Okay. And then Caitlin said the sum of your 2 uniform number is the date of my birthday later this month. Okay. Let's write it down. So C actually has a late birthday later this month, and Bethany has a earlier, right? This month has a birthday earlier this month, and then Ashley said the sum of you 2 uniform number is today's date. Okay. So basically we have A plus B is today's date, right? I mean, B plus C is today's date, I'm sorry. Okay, so, and you ask about what number does Caitlin have, okay? So they're all 2-digit primes, right? So how many 2-digit primes are there? There are a lot, right? But we only want the ones that are kind of small, because you add them up, you get the date. So it has to be between 0 and 31, right? So we would have, let's try some more. So 11, right? 13, 17, 19, right? 23. That's already too big, right? Yes.
I'm pretty sure that there's 21 2-digit primes.
I'm sorry.
I'm pretty sure that there's 21 2-digit primes.
Oh, you mean between? I mean all the 2 digits. Yes. Okay, that's good. I didn't know that. So there are 21 primes in total, right? Okay. Okay, so basically, let me see. So B said that the sum of these two uniforms, so which is A plus C, is an earlier birthday, right? And then we know that A plus B is a later birthday, right? So what does that mean? So that means C must be smaller than B, right? So if you add C to the same number A here, you get an earlier birthday than the B, okay? And then what else do we know? We know that B plus C is today's date, right? So B plus C is today's date. So it's kind of between A plus B and A plus C, right? So we know that B plus C is between A plus B and A plus C, right? Okay. So then basically you know the order of these three numbers, which is A less than B, and C is less than A. So C less than A less than B, right? Okay. So then you can just try these numbers. So which ones are possible? Yeah, that's the only thing that is possible, right? If you choose these three numbers. If you get 19, it's already bigger than 31 if you add two of them, right? So it has to be 11, 13, and 17, right? So the answer for number 23 is 8, right? So K-Ling is wearing 11, actually, the smallest. All right, so number 24. So one day, the beverage barn sold 252 cans of soda, so in total, 252 cans of soda to 100 customers, right? And every customer bought at least one can of soda. Okay? So then what is the maximum possible median number of cans of soda bought per customer on that day? So we want to find the maximum median possible, right? So everyone knows what the median is, right? So if it's an odd number of items, then the median is just the middle one, right? If it's even number of items, then the median is going to be the average of the middle two, basically, right? Okay. So here we actually have 100 customers. So the median would be the average between the 50th and the 51st, right? So basically, I only care about what's the maximum possible number for these two customers, right? So then we have 52nd, etc. And before that, we have 1 to 49, right? Okay, so we know that we have 100 customers, and each one bought at least one can of soda, right? So we want to make the addition between the 50th and 51st as big as possible. So what should I put here for the first 49 people? So I should set 1 for each one of them, right? Does that make sense? So for these ones, for these customers, I wanted them to take at least possible as cans of soda, right? In order to make these numbers bigger, right? But once again, I can't make them too big, right? Because all the other guys, they would have bought at least as many as the 51st people, right? So we're just trying here. So for example, we only have, so the first 49 people have 1, right? So we have 252 subtract 49, so that's how many cans of soda do we have left, right? So we have 203, right? Okay, so let's try it. If, say, all of them bought, say, 3 cans of soda, is that possible? So we only have 51 people left, right? So if each one bought 3, 3 is okay, right? So we have 153, right? Which is less than 203. That's fine. What about 4? So if each of them bought 4 cans of soda, that would be 204, which is 1 bigger than 203, right? So that's too much. Okay, so how do we reduce the number by 1? Make the 50th by 3 and all the others by 4, right? Then the number will be reduced by 1, which is exactly 203, right? So that's the best we can do, because if this if this person bought 4, then we're already out of, we run out of the cans of soda, right? So it has to be 2 or 3. So that's a maximum, that's a best arrangement actually to get the maximum median between the 50th and the 51st, right? So the average is actually, the median is the average between these two, which is 3.5. So the answer is C for number 24. Okay, the last one. So we have a straight line, 1 mile stretch of highway, 40 feet wide. So the highway is 40 feet wide. Is closed, and Robert rides his bike on a path composed of semicircles, as shown. So basically, it's doing something like this, right? Etc. Okay. So if he rides at 5 miles per hour, that's the speed, 5 miles per hour. And how many hours does it take to cover the 1 mile stretch? Okay. So this whole stretch is 1 mile, which is 5,280 feet, right? So just keep the same unit here. But he goes through the 1 mile this way, right? Like semicircles. And you ask about how many hours does it take? Okay. So how do we do this kind of thing? So we know the speed, right? And we want the time. So basically, yes. Yes, so we're trying to find the distance. We're trying to find the time, right? So basically, we only need to know the distance it covered, right, in this pattern for the 1 mile, right? So how do we do that? So how many semicircles are there? Yes. So it's 5. 5,280 divided by?
40.
Is that
Diameter.
Yeah, 40 is a diameter, right? So the 40 is a wide of this road, which is the same thing as 2 times the radius, basically, the diameter, right? So if you use that divided by 40, then you see how many cycles are there. Because for each cycle, it covers this much, right? 40, I mean, this much distance, right? Which is, so if you compute this number, you get 132, right? Okay, so in other words, there are 132 cycles in total. So 132 cycles in total. Now each cycle is a semicircle, so you get the total length would be 132 times pi r, right? Which is
25.
pi times, so what is r? R is
20.
Yeah, r is 20, right? So this is the total distance you covered by going this pattern, right? So this number is actually 2640 pi, right? And then you should divide this by the speed, which is 5 times 5,280. Change this to feet per hour, right? And then if you compute this number, you get pi over 2. Yes. So the answer is B. Pi over 10. Right? So the answer is B for number 25. All right, so sorry for running late today. It's a pretty late. Because next time I probably just select the common problems that made mistake first, and then if you have any further questions, if you have time, we can go over the rest. But today I'm not prepared for the homework, so next time maybe if I get your results back early, I can select the corresponding homework problems for you to do. Okay. So for first week I haven't decided yet because I just got their result back like this evening. But for next time, I'll find some homework based on